So I love tests. Tests are great. They find all kinds of problems in my code, especially when I'm refactoring code, especially when I'm adding new features to existing code. So I really, really love tests most of the time. There are odd times, maybe, I don't know, 5%, 10% of the time, where I really, really hate my test suite, and I think it's more trouble than it's worth. And normally the problem is I have lots of tests and they're all passing, and then I make a tiny change to my code base, just a tiny little change, just something pretty inconsequential, and half my test cases just all turn to failure. And it makes me sad. And one of the reasons why this happens is because of the coupling between our tests and the code that we're testing. And the whole purpose of this talk is I believe that decoupling our tests reduces the overall cost and time and maintenance time of a test suite. And hopefully, by the end of this talk, you'll agree with that too, and you'll see some strategies that we can use to kind of reduce the coupling between our tests and the code that we're testing. But why is this important? If we think about what our value of our test suite is, there's the costs for any bugs that our test suite finds or prevents us from introducing over the whole lifetime of that project, minus the cost of actually the test suite, and that is developing the test suite and to keep it maintained and keep it going. So what we're looking at today is how we can reduce the costs of our test suite to increase the overall value of testing. So I'm Dave Liddament. The only thing that's really of interest with regard to this talk is I've been writing software for quite a long time, and at least half of that time I've been using some form of automated tests, and I made lots of mistakes, of which we will learn more about them and some of the solutions as well. But before we get into that, we're going to talk a bit more about why decoupling is so important. We're going to talk a bit about terminology, just because there's lots of terminology around testing that is maybe inconsistently used. And then I'm going to give 3 stories from my time developing software and the lessons that I learned the hard way, so hopefully you can learn it a much easier way. But before we start, I'm going to have a little confession here. I was writing some code, and I wrote some tests, and that was all good. And it was near the deadline, as you do. You get near a deadline, and then I had to make a small change to the code, and a load of the tests broke. And my confession is, I thought, you know what, I'll just ignore those tests. I'll come back and fix them later. And my next confession is that 6 months later, all of those tests that I'd ignored, I had still not come back and fixed. And then my final confession is a year later, those tests that I had ignored were still ignored. They still weren't running. And I could do more confessions, but I'm going to stop there because really that project's been going on for a long, long time now. And the problem really was that all of these tests were there to prevent problems coming into my code base. There would be, and because they were ignored, that means they weren't run. So that's whole areas of my code that had no automated testing. That's whole areas of the code base that when I'm changing the code or when I'm adding new code that interacts with the existing code, there are opportunities that bugs could slip in. So that's bad, and we don't really want to do it. And the reason that I just ignored those tests was because I'd made a tiny little change to the code. And that change I did all the way back, 5 years ago, that was fine. It wasn't an issue. The tests, the reason the tests all failed was because they were poorly written and they were tightly coupled to the code that I was testing. So I've mentioned the term coupling. Let's go into a bit more detail about this. So imagine we've got 2 parts of our system. So we've got A, our application, and B, maybe that's something that's sending emails, an email gateway. And initially, these 2 things know nothing about each other. So if they know nothing about each other, they don't even know each other's existence, there is no coupling. And the problem with no coupling is we cannot make use of the 2 bits of code. So if A, our application, wants to send an email, and let's say B is the email gateway, there has to be some knowledge. A has to know something about the email gateway. But we want to make that, the amount of information it needs to know about B as minimal as possible. So if we're sending an email, maybe all we need to tell our email gateway is who we're sending the email to, who it's from, the subject, and the contents of the email. So that's a minimal amount of information that A needs to tell B in order to send an email. But let's say maybe we haven't developed our email gateway particularly well, and we need to know about some of the internals of the email gateway. Maybe the application needs to know how we're actually sending the email. Maybe the application needs to know something about the credentials used, or something like that. And the problem is, we've now increased our coupling. Like, the application knows more about B, the email gateway. And the more it knows, the bigger the problems are. So if we make a small change to the insides, the internals of how our email gateway works, maybe we have to make additional changes to our application. So the changes we make in one part of the system ripple over to here, and maybe there's other parts of the system that talk to A. And because we make a change in B, we make a change in A, and if they've got this tightly coupled, or this high amount of coupling, then other things talking to A might also have to change. And that's kind of when you've got tightly coupled systems or tightly coupled bits of code, and we want to try and avoid that if possible, because if we make a change somewhere, it could ripple. We might have to make lots and lots of changes. And the other benefit of loosely coupled or low coupling is if we imagine, again, our application's talking to an email gateway, the thinner the interface between those two things, the easier it is to make replacement versions. So one day, B could be something that sends emails via SMTP. The next day, B could be something that sends emails via Mailgun. The application doesn't know, and it doesn't care. It just says, go send this email. And the other thing we can do, which is relevant for testing, is we could replace the real implementation with a dummy or fake implementation. That's used, is used for testing. So the test one won't actually send the emails. It will just remember, we were asked to send these emails. And then later our test could ask, was this email sent? So generally, the lower the coupling or the looser the coupling, the easier it is to do testing. But also, there's lots of benefits beyond testing as well in keeping our parts of our system loosely coupled. So the other thing I want to talk about very briefly is the test pyramid. And this is how some people say we should divide up our tests. So we've got lots of unit tests, not so many integration tests, and very few tests UI. So those aren't testing the user interface. It is testing the application via the user interface. That's what I mean in this context. Generally, at the bottom of the pyramid, these tests are fast to execute, they're quick to write, and then as you move up the pyramid, generally the tests are more expensive and take longer to write, and generally they are slower to run as well. So remember, the whole purpose of this talk is I'm going to claim that decoupled tests reduce the development costs of our test suite. And let's now talk, let's go through story one. So my first story is about a project I worked on a while ago. And what it was is people were placed in teams, and every so often a quiz was released, and the members of the team would go and take the quiz, and they would get scores. And the teams were allocated scores from the player, from the people who were in their team. And the team with the best scores and the highest participation, they won a prize every quarter. Now, from time to time, people moved from one team to another, and at the point they took the test, their score had to be associated with that team. So if I started off in one team and I moved to the other, and then I took the test, it would be the second team's score. It would be the team I was in at the time who would get my points. So a typical user story is you would log in, you would look at a list of quizzes, you would pick one that you hadn't done, you would do it, and then you would get your score, and your team would also get the score. Your team's overall score would be updated depending on how well you did on that quiz. So suppose we wanted to test something. Does the individual score get allocated to the team they were in at the time? You know, that's a reasonable thing to test in an application like this. And it's quite an important thing because people move from team to team all the time. Now, lots of code had been written, and initially all of the testing was done in a manual way, using the user interface. And this was quite a painful process. And in fact, it was so painful, we decided that we needed to automate it. So we started writing tests. And our tests were done via the user interface. So we were writing tests that would actually kind of, go to the website and click on things and so on and so forth. So our tests would kind of look a bit like this. You'd visit a page, you click on the link, you'd fill in a form element, you click the next button, you fill in another form element, and so on and so forth. And the problem with a test like this is it's not really clear what we're actually testing. There's lots of detail, and if you think about the big picture, it's not really obvious that's what we're doing here. And of course, you might get like tiny little change requests that come along and say, actually, you know what, we want to change the layout of the page that's showing a list of all the quizzes. And what would happen, our tests would go from all passing to all failing, or a lot of them would be failing. And this is a bit like my confession. It was one of those kind of changes. We made a tiny little change to something, maybe moved a few elements around, and suddenly half the test suite broke. So yeah, there was obviously a problem how I was doing testing via the user interface. And the problem really was we've got a very tight coupling between the test and the software under test. We need to know a lot of detail when we're trying to test, like, essentially business logic. Is that person's score associated with the correct team? So what we need to do is try and reduce the coupling between the tests and the software under test. And what we can do is between our test code and our software under test, we can put something in called a page object. And what that does is the test talks to the page object in terms of, like, I want you to log in. I want you to answer this question. And the page object talks to the software under test in kind of conversation like, I find this element and click on this link and do this and do that. So so we're starting to kind of decouple here. So if we have a change to our software under test, we just need to make one or two changes in the page object, but this side of it will stay all the same. So a page object can do anything a human can do. It can interact with a web page. It can grab data from the page. It can navigate to another page, and so on and so forth. And the reason this reduces coupling is because we make a change in our software under test, and we just need to change just code in the page object. We don't need to change anything about our tests. And the reason that's really important is because, in reality, there'll be lots of tests doing some very similar interactions. Like virtually all our tests will probably have to log in, or lots of our tests will do things like, I'm going to submit a score. So what we've done is we've isolated changes to just one place. So something about the software under test changes, we just need to update the page object, but all of the tests that use that remain the same. So our tests are starting to look a bit higher level now. And remember, we're not trying to test elements of the user interface. We're trying to test, does this actually perform correctly? So now we might be saying, I want to log in, and then I want to go and find a quiz, and then I want to edit, set some answers in, and then I'm going to go and submit that quiz, and so on and so forth, and then I'm going to go and get the score. And that's better. That's certainly better than what we had. But even now, it's not quite. This test is still quite detailed compared to what we're trying to do. And we can still come a cropper. So if somebody says, "Oh, we're going to make this tiny change," when we log in, we're going to change what page you go to after the user logs in. And that means any tests that have a line like the second line in the test will suddenly fail. Okay, they were passing and then they suddenly fail, and then we get to our tiny change breaks half the test suite. So what we need to do is reduce coupling further, and what we can add in is a layer between the tests and the page objects. I've called it a DSL, like a domain-specific language layer. And that talks in the language of submit to users' answers or get a team score. So this is quite high level now. This is quite a lot closer to what it is that we're trying to test. The DSL will talk to the page objects, and the page objects will talk to the software under test. So if we had something where we say, I'm changing the order in which we log in, we've just got to change something here, but everything else remains the same. So our tests are now starting to look a bit like this, We assign a user to a team, we submit the user's answers, we get the team score, and we check it at whatever value we expect it to be. And let's remind ourselves of what we're trying to test. We're saying, does the individual score get correctly allocated to their team? You can see if that's what we're trying to test, and we can read our test, we can see that that test is doing the right thing. And the purpose of what we're doing here is we're trying to test the application is behaving correctly, and we're doing it via the user interface. So kind of in summary, if we are going to go and test our application via the user interface, we probably, for most things, certainly at the higher level function, we probably need to put in several layers, 1 or 2 layers or maybe more, between our tests and between the software under test. And the key thing here really is our tests should only change when a business requirement changes. If some little detail about the layout of the page changes, well, that's all covered off in these bits here. And this was quite an old example. Nowadays, people do more interesting things than write plain old HTML sites. So maybe, our DSL, our domain-specific language, might be talking to page objects, but it might also be talking to something that gets things or takes things off queues, or it might be talking to web services. But again, what we're trying to do is if we're testing our software as a black box, we probably need some layers between our tests and the thing that we're testing. So the morals of the first story is if we're going to test an application's business logic via the user interface, it is difficult. It is time consuming, and we need to do things like introduce layers between our software under test and our tests to help protect us against changes. And the key things are we really want to have tests that the tests do not change unless the business requirements change. And probably of no relevance to you, but I hated doing these kind of tests. So, remember the whole point of this talk is say decoupled tests reduce the overall development cost of a test suite. I hope you can kind of see from that story where I'm coming from and potentially some ways you can design your test in such a way to reduce the coupling and reduce the overall cost of your test suite. But what if? What if we replace our entire website with an app? Or we completely change the website, or we do something else? There's a lot of rework doing what I've just suggested here. It would be quite difficult. So kind of this comes on to my second story. I thought what we'd done in the first story was definitely an improvement. Things had definitely got better. But I still thought fundamentally this isn't a very sensible way to test an application. And there was a couple of changes that were going to be added. The first thing is people would have to pay to complete their quizzes, and also we would then start sending emails. So once you finished your quiz, you'd receive an email that said this was your score, and your team would get an email to say this was the team's new score. So those were 2 bits of new functionality. And if we were using the existing approach, we've got the software. Normally it'd be a black box, you can't really see inside it, but it's a big purple circle there. And our only interfaces to it would be the website, and then it's going to send emails, so there'll be some kind of email system and some payment system as well. So it's actually going to be quite hard to test these additional new features, the payment and the email gateway. Like, would we have to write some code which it would send the email somewhere, and we'd then have to try and work out if that email had been sent? And the payments, could get quite expensive if every time we run our test we had to actually buy things. So I thought there's got to be a better way of testing these things. And in software, all the difficult problems are largely solved, and you just got to find out how people did them. And there's kind of quite high-level concepts of layered architecture and hexagonal architecture. Now, I'm not going to go into these details now. I'll just kind of explain roughly what they're trying to achieve. But if you've not heard of those concepts, it's well worth having a look more into them. So what we really want to do is, instead of having a big blob of code, we kind of want to go inside it slightly. So what we've got is, in the center of this circle is our business logic. So that's the code we're really interested in. That's the code that's making sure that we're assigning a player's score to the correct team. Then we've got to connect this business logic to the outside world. So our websites, we'd often, would have controllers to talk to the business logic. And then we've got our email gateway and our payment gateway. And instead of talking to it directly, we'll have an adapter between them. And then this green circle is kind of a thin layer around the business logic to an easy interface to the business logic. And the key thing here is that the inner circles don't know anything about the outer circles. So the business logic has no idea it's part of a web application. It doesn't know what framework it's in. It doesn't even know what it's talking to or anything like that. It doesn't know the exact payment gateway or how emails are actually sent. It just knows it's going to send emails and make payments. So this is where we really want to be with our code. Our service layer might have interfaces to it, something like this. So we might have an answer submission service where we're going to submit our users' answers. We can say, this is the user, this is the quiz, and these are their answers. And there'll be lots of similar a service layer is one way of talking to your business logic. There's many other ways of doing it. But essentially, you want a nice, thin, easy interface to your business logic. So whereas before, we were testing our application via the user interface, now we're operating a bit further down the test pyramid, and these kind of integration tests or service layer tests. So that's all very well and good. But if the business logic isn't allowed to know, if the inner circles are not allowed to know about the outer circles, well, how then do we send emails or make payments? So what we do is we'll have interfaces. So the business logic will have a payment gateway interface, and it will just say something like, you're going to make a payment for this amount. The email gateway will have an email gateway interface, which just is like send an email. So the email gateway might be something as simple as this. We're sending an email to, it's from here, the subject's this, and this is the message. And it's an interface. We don't actually know how that's going to be implemented, and actually we don't care. All the business logic knows is I've got this email gateway, but the actual implementation details, it doesn't know anything at all. So the real implementation, well, that's probably kind of in your framework. If you're using Laravel or Symfony, they've got things like, I can't remember what the mail service is now, but for sending emails, and there'll be libraries to connect to payment gateways. So and the real implementations would be injected into your business logic. But the business logic doesn't know anything about them. And the great thing about that is we can then replace the real implementations with test ones. So for example, instead of putting a real email gateway in, we could have something called a spy. It has to implement the same email gateway, so it has to have a send method. And instead of actually sending an email, this would maybe just save the fact that an email was requested to be sent and store it in an array. and then you'd have an extra method on there that just gets a list of the arrays. So that means your test could say, hang on a minute, I was expecting an email to be sent to Bob, and was an email sent to Bob. It can just run its test, and then at the end of it, just say, was that email sent to Bob? And because we've got loosely coupled code, it's really easy to provide alternative implementations. For the real email gateway, we can just put in a simple email gateway spy. So testing is becoming a lot easier as well. Our tests, we're probably talking about things like submitting the answers. There might be a very thin layer between that and our software under test. But in fact, it might be you can just talk directly to the service layer, because actually now we've made a kind of interface to our software under test, which is just kind of almost talking in the business language. So the thing is, by architecting our code this way, instead of having to worry about talking to real websites and worry about real email gateways and real payment gateways, what we can do is we can just get rid of all of those. We can put our test doubles or our spies or replacement versions, and our test entry point, instead of at the talking to a web server, it just talks straight to the business logic. And think how much easier it is than if our test entry point was the whole system itself. I mean, it would be very difficult to kind of work out if payments have been made or not. So that is all very well, but it means you have to architect your project in this way from the start. And that's all very well, but if your project looks like this, it's just a big mess of things, then what do you do? And well, it's kind of, what you would do is you'd kind of work out your external touch points. So first of all, I would probably pull all the code that talks to the payment gateway and put it into a payment gateway adapter. I'd do the same for emails. I'd make sure our controllers were just responsible for taking web requests and returning responses, and they weren't doing any of the business logic. And then eventually you'll get to a stage where all your business logic is together, and then you can put a nice layer around that, the service layer, to make it nice and easy interface. It's often quite a lot of work, that. It's better to start and do it right from the start, but if you haven't architected your project right, then this is kind of the steps you would take to get to that point. So I think this is a really powerful place to do a lot of your testing at this level. Unit tests are still essential, but often you've got lots of bits of your code working together, and the only way to test it is kind of integration level or higher, but often it's easier to architect your code in a way to test, and the tests are certainly much easier done at this level. So if we're doing the majority of our testing here, do we still need to test our application via the user interface? Well, yes, but we're asking a slightly different question now. All we're asking is, if we assume the layers below work perfectly, then what we're really asking is, have I connected the user interface correctly to our application, our business logic? So actually, before, we've got all of these tests, and what we need to do is just pick a handful of them that give us enough confidence that our user interface is correctly connected to our business logic. So you just look at all of your tests and go, well, we've run that one and that one and that one. We'll convert those into testing via the user interface. And we've kind of got an option. We can try and automate them, or we could do them as manual testing. You've kind of got to, it's difficult to know what is best. It kind of depends on many things there. But yeah, you certainly want to automate all of your tests at the integration level, and then just work out which of those you need to prove that you've correctly wired everything together. So the moral of the second story is testing an application's business logic via integration level is much easier than trying to take all the software and test it through its user interface. You'll probably find, I mean, if you think about things, long-running projects, their core business logic probably doesn't change, or it only evolves with new functionality and new business requirements. But your website, your web front end probably changes, every 4 or 5 years. And 10 years ago, nobody had apps. Now everyone's got apps. But your core, business logic probably hasn't, evolved that much. So it's much better to test our business logic not via the user interface. But if we're going to do that, we need to think about the architecture of our code. There'll be so many benefits in architecting your code in this layered approach anyway, not just with testing. So I'd advise you to think about these kind of things when you're building software. So remember, the whole purpose of this talk is that I believe that decoupled tests reduce our overall maintenance costs and development costs. Hopefully you believe that, and hopefully you can start seeing now ways you can design software to make it easy to test. But there were still parts of my system that were quite tightly coupled to my test suite. So for story 3, the project was extended a bit further, and the main changes now was each company had their own login page, and you could only, and it was all branded, and you can only log in from your company's subdomain. So before, when you logged in, you had your username and password. Now you had your username, your password, and your subdomain. It's, you know, that's a fine change to make, and actually it shouldn't affect most of the system. But we made the change, run the tests, and we had loads of failures. And you kind of think, why, when we're testing this, does it matter that suddenly we've said that when you log in, you've got to give your company's subdomain? And the reason was, it was all to do with how we were seeding our databases. So often for tests, when you're doing user interface tests or integration tests, you need to have your the data in your system in a certain state, in your starting point, that you then do your tests on. So you say, I'm going to have my data in this state, then I'm going to do something, and then I expect the outcome to be this. And we'd cobbled together something to put data into the database. So we had all our data in YAML files. And what it would do is it would look at this and go, this is my user table, and I'm just going to put all this information in. So I'm going to have an entry with a name, email, password, and team. And it would just iterate through these YAML files and just dump them straight into the database. And the problem was, it's not a very good way of seeding a database, because what happens when we make a change to the structure of the database? In this case, we'd added a reference between a user and the company. So of course, and it was a mandatory that every user was associated with the company. So all of our database seeding scripts had to be changed. We had to go into every single one of our YAML files and add in a reference to company. So this isn't really a good way of doing things. You don't want to take data directly from a YAML file or equivalent and put it straight into a database. You probably need to go via an intermediate stage. So we're going to talk about ways we could actually build our data that we need. So data fixtures, the data we need for our tests. So one way we could do it is we'd hand build it. So instead of using the YAML files, we could just go and write some code via the service. And then if something changed, like suddenly there was a requirement for a company, we just have to go through everywhere in our code and add this in. So this really isn't a good solution, because the chances are you're going to be doing this several times. So we don't really want to hand build our data every time we need it. Another option is something called an object mother. And this is just, I suppose, it's like a builder, it's like a factory or builder. And what it does is, if you need data of a certain type, you just go to your object mother, and you just say, get me some data of that type. So for example, to build users, we might have a user object mother, and then if you're using personas, maybe we've got someone called Anna, and she has whatever properties Anna has. So you just call get Anna, and then you get a user that is a user called Anna. And maybe Anna's an admin user or whatever. And the purpose of this is we're delegating all the responsibility for creating this user to the user object mother. And maybe the implementation looks something like this. It may, behind the scenes, it probably calls our user service to register a new user. But it means that if we change how we create users, there's just one place that we need to make that change. And then everywhere else in our tests, we can just say, look, get me a user who's type Anna or a user that's type Bob or whatever. The key thing here is we're reducing the places that we need to, when changes are required, it's just one place we need to make that change. So we're decoupling, when I say I need a user of this type, we've kind of, the test doesn't really care how that user is produced. We're just offloading that somewhere else. So that's the object mother. A test builder is a very similar concept. You would create a builder, and then you say, user builder, build me a user. And this would just, again, build you a user with a set of default values. And if you want to override them, before you call build, you do user builder, and you say, actually, for this test, I want to have a user who's called Annabelle with this password and is in Team Banana. And again, what we're doing here, object mothers and builders, they might also refer to other object mothers and builders. So our user object mother, if we suddenly make a requirement that a user is linked to a company, well, the user object mother would have to know about the company object mother, and it would say, all right, before I build my user, I need to go and get myself a company, and then I can put that information into the user that I'm building. So again, and you'll find the same with builders as well. You might, if you're building complex objects, a builder might need to refer to other builders, which again might need to refer to other builders. But you're just, if anything changes in how we construct companies, this code doesn't care. We've just moved it to one point. So if we did have all our data in a YAML file, what we probably need is some kind of hybrid approach. So yes, we can read all this data out, but we don't put it straight into a database. We go through one of the builder patterns I've mentioned to create an object in a valid state and then put it in the database. And if there are changes to the data structure, well, that's fine because there's only one place we need to make that update. So the moral of this final story is when you're creating your test data sets, you're building your data fixtures, think about using things like object mothers and test builders. Because it makes a test more robust to change, especially when you change something about your data structures. And again, we've kind of decoupled our tests from our software under test. So this was the point of this talk. Hopefully you're convinced, and hopefully you can see some ways in which to start thinking about how you build your code to make your test suites, lower the cost of your development and maintenance costs of your test suites. So kind of in summary, if you have to test via the user interface, think about this layered approach. Better still, try and do the majority of your testing slightly further down the test pyramid, so not testing via the user interface if you can test most of it at the integration level and below. And finally, if you are building test data, think about how you're going to, from whatever your data sources are, maybe the YAML files or similar, into your database or your data store. I've been Dave Liddament. Thank you very much for listening. Any questions?
I got.
Yeah.
You did mention the one at the bottom, which should be unit test.
Unit test, yes. Didn't really have time. You do need to use unit tests. But now, if you think about some of the concepts we've discussed, they're still applicable at unit test level. In fact, the test builder pattern, I use builders a lot in my unit tests. Because if you're constructing, say, a person object, if something changes about that person object, and you just delegated that all off to a builder, you've just got to update the builder once. And all your tests, instead of saying new person, you do person builder, build, and it would build you a person object that's the same. And actually in unit tests, well, in fact, all of the tests, the other side of it is your assertions. So if you have, I'd often write custom assertions as well. So if you often find you're doing, you've got 3 or 4 assert statements all together, that is probably a sign that that's something that could be converted into a custom assertion that you'll use everywhere. And then if something changes about, like if you're asserting something on a user object, and something about that changes, you've only got to change the assertion there. So yeah, think about in tests, you've got arrange, act, assert. So your arrange and your asserts are areas where you probably want to think about abstracting that away in non-trivial cases.
A bit earlier on you mentioned, or you showed a spy class. What's the benefit of using something like that, of using like a package like Mockery to mock class implementation in a test? Or is it kind of a similar thing?
I'd say it's a similar thing. Very briefly, I suppose you've got stubs, mocks, spies, and fakes. So if we think about our email gateway, is it a good example? Think about our payment gateway. Maybe that's a better example. Maybe you have lots of your tests. Like the happy case is the payments always succeed. Okay, so imagine you've got a payment gateway and the interface sort of says, I want you to charge this amount to this person, and you return true or false. In reality, it'll be a lot more complicated, but simply it either succeeds or it fails. Now, most of your tests, probably the payment succeeds, and it's just incidental to kind of getting you to a certain place in your test. So most of the times you could use something called a stub, and actually that doesn't even care about any of the data it's being given, and it just says, yeah, that whatever you give me, I'm going to tell you that payment was successful. So for any test which you don't care about payments, you'd use a stub. And then the next level up is either, I suppose, a mock or a spy. What a spy does is you'd run all your tests, and at the end you'd say, I was expecting a payment of £17 to Bob. And you look through all the payments and check you received, one of those was requested. Now, so you'd probably have to handwrite your spies. Whereas if you're using a mocking library to create a mock, what you do there is at the start of your test, you say, I'm going to create this mock object. So it behaves the rest of the system. It just behaves like a payment gateway. And you would say, I expect this to be called, I don't know, exactly with these numbers. And, I expect this to be called, once with this value and these things. So, to be honest, you can use either. I think when it gets to integration tests, I probably always favour spies anyway, because then it's just part of code. And then when things like change a method name, you've got your tools to do all the refactoring. And I know maybe they can be clever enough to help with the mocks, but I don't find them as clean at integration level. I might use them at unit level. I don't know, it's kind of depends a lot on the situation, but there's no right answer there. So I'll just waffled on for 2 minutes. Sorry about that. Any other questions? No? Brilliant. All right.